Okay, in this video we're going to be talking about histograms. So let's get started. What is a histogram? A histogram is a graphical representation of the distribution of data. So what you're looking at right now is a histogram. And I know what you're probably thinking. It looks like a bar graph. And in all honesty, we're not going to get that far, we're not going to get that advanced into this for right now. So if you're thinking it looks like a bar graph, and if that's what you can remember it to be, then okay, we'll go with that for now, okay? And I'm sure some mathematician is rolling over in his grave right now. All right, let's keep on. An example of a histogram when you're trying to solve problems. Here we go. A histogram shows the heights of 21 students in a class grouped into 5-inch groups. Now, a couple of things I want to make sure that we can do first, and that is to read the histograms. And so, And so what we have here is on the side, we have the number of students. Okay, so this is the number of students. And as you read it, this is the 50 to 55-inch category. So if I was to ask how many students are in the 50 to 55 category, well, you just read off the side, 1, 2, 3, there's 4 of them. Okay. The next one, how many are in the 55 to 60? That would be 6, because that's where the bar, so to speak, goes all the way up to 6. And hopefully by now you can pretty much figure out how I'm doing this. This is 2, this is 3, and this is 1. See how the 21 students has been distributed throughout the graph. So the question, how many students were greater or equal to 60 inches tall? So really quick, 60 is right here. So that means everything, and of course this is the 60-inch line that I'm highlighting in purple here. So that means everything from this line over will be my answer. Let's see, 5, 2, 3, 1, that's 11. Okay, moving on. A couple of definitions, and I'm going to kind of speed through this a little quickly, so you might have to pause the video. So categorical data is when the information is gathered in categories. Notice the example that I gave you is that all the information here is in nationalities. Okay, so it's not like I'm not grouping them through anything other than categories. And of course, there's many different examples, and I just use this. Democrat, Republican, you can do male, female. Those are all different categories. Moving on. Quantitative data, and it's when the information is recorded numerically. Notice now in this, everything that is, all the categories down here are now in numbers. So that would be quantitative. All right. Univariate, I don't think I pronounced that right, but one variable is where you're only using one thing to get information on. Now, of course, this is an example here, but let me use the examples I wrote. It's like if you are only using height or only using weight to determine the information or distribute the information. And lastly, bivariate. Hopefully I pronounced that right, I'm not sure. 2 variables, that means where you're using 2 variables to record information about each participant. So like for example, if I was using a height and weight combination to get my information, that's what it is. All right, let's talk about types of histograms, all right? Now, these are what is called symmetrical, and the reason they're symmetrical is because of the fact that basically everything on the left is the same as everything on the right. So like going back to symmetrical, let me give you a quick kindergarten example of symmetrical. So if I was to draw a square, and if I was to cut the square in half, everything on the right is the same as everything on the left. It's the same concept for a histogram, except one thing, and that is you have to first determine, okay, what is kind of like the constant line, or if I drew a line, what would be the constant kind of, what's a good way to say it, distribution of my data here. Notice in this very first one, it kind of makes what looks like a bell curve. Now, another thing, when you're dealing with symmetrical in math, you're never going to get 100% symmetrical. It just doesn't work that way. So you have to get kind of a general thereabouts overall look at it. So if I was to look at this, notice that the concentration of data is in the center and it kind of tapers off on the left and right. So you would say, yes, this is symmetrical. Now this one over here looks a little more challenging, but if you were to kind of draw a line summarizing the way all the information is given here, notice that it kind of goes up and then comes back down and it kind of comes back down. Now notice once again, it's not going to be 100% symmetrical, but if you see a pattern, see how it kind of goes up in this area here, and then it's the same in this area here, and then in the center it gets a lot bigger here. This would be symmetrical. Okay. Now the next type of histograms, this is where it gets a little confusing, and that is skewed right and then skewed left. The reason it's confusing is because all the information is actually on the left-hand side of the skewed right. The reason it's called skewed right is because as the information tapers down, it tapers down to the right. And I know that's confusing, but that's just how it is. So skewed right, in short, is almost like opposite, where all the information is on the left and the information tapers down to the right. Same concept with skewed left. Notice that all the information is to the right and then it tapers down to the left. So that's called skewed left. I know it's confusing, but you're going to have to remember it. Okay? Last one. An outlier. An outlier is an observation point that is distant from other observations. Notice that all my information is right here. Okay, all my information right here, and then all of a sudden I just have this one thing or one person way over here. This would be an outlier because of the fact that this information is not connected to this information in a way. So you would say that is the outlier, or you can say is, I don't know, maybe the exception. Sometimes you can look at it like that. All right, let's go for a couple examples here. Does the histogram illustrate univariate data or bivariate data? Category or quantitative? All right, so let's talk about the very first one. Univariate or bivariate. Notice what is going on here. All this information on the bottom is the semester average. Okay, that's the only thing we're doing. That's one, so that means it is going to be univariate. Okay, one variable. Now the next thing would be categorical or quantitative. Now remember the definition between category. You're dealing with categories in which people are being kind of put into categories, you know, male, female, you know, maybe their age or something. It's hard to think off the fly here. Or quantitative. Well, this would be an example of quantitative because notice that all the information is in numbers. Okay, so univariate and quantitative. Would you describe the histogram as symmetrical? Why or why not? Or symmetric? Well, let me clean up the histogram real quick. Now, looking at it, no, it's not your kindergarten definition of symmetrical because of the fact that there's just difference. But if you were to draw a line just kind of summarizing the way the data is being dispersed, it's kind of in this format. Now, if you notice, cut it directly in half, that looks pretty symmetrical. So is it symmetrical? The answer is yes. Let me draw that again. The answer is yes, it would be symmetric. Okay. Describe the distribution of grades for the class. All right, so describing the distribution of the grades of the class. All right, so in other words, let's make an estimation, okay? If I was to look to see what would be the average semester grade for this class given this histogram, I would say that the average would be somewhere, I just say somewhere in the 80 to 81. The reason I say 80, 81 because the most of the data is right here, right between 75 and 85, but it's actually skewed a little over here. So I would say, you know, it's 81. But let's figure it out using the actual histogram, okay? Now, if I was to ask you, going back to that example that we did 7 minutes ago, how many people actually made a 65? That would be 2, because I'm reading it. 75 would be 7, because I'm reading it off to the left, 7. That would be 9. And then how many people made a 95? That would be 3. Okay? And so now what I would do is I'd find the average. I'd take 2 times 65, 7 times 75, 9 times 85, 3 times 95, and get my average. which after I do all that, I'd add all this up, multiply, and then I would divide everything by, let's see how many students there are, 21, because there's 21 students. I would get 81.2, I think. It might be 81.4. But either way, that's how you do it. And that's histograms. Let me know if you have any questions. Thank you.